And I want to start with that because it really gave me the idea of what I'm doing. So when somebody told me this story, I understood. I've been studying social network analysis for like 12 years, but then I thought, okay, I need to combine it with the analysis of contents of the language and communication, which is also a part of many relationships that can be tracked with social network analysis, right? But really the power of words, I discovered it from Freud, for example, because if you think about how the language developed, when the words were first introduced, they were used to make magical formulas, where they were used by sorcerers to heal people. So nobody was using words apart some elite of people. So they were very precious. But then I read of Freud and of the work of Václavic and other people, and I read that words retained much of their original magical power, because with words, for example, I can make a person blissfully happy, or I can drive them to despair. So with words, we can change behaviors. And I discovered it with this, with the story of this guy who was a blind man asking for coins outside a big mall, right? And there is a famous man working in advertising at the time. He went to the mall and he sees the man, and he put the hands on inside of his pocket and search for like €2, some change, but it doesn't find it. So he thinks, okay, I can go shopping, I can go to the mall, and when I go outside, I will give some coins to the man. And he does. He stays in the mall for like 2 hours, and he has the €2 ready in his hand when he exits. But what he notices is that the head of the man was pretty much empty till 2 hours before, okay? And the man had a label in his hands where it was written, please help me with an offer because I cannot see and it's difficult for me to find a job. So he decided why nobody gives this man an offer. So he decided to look at the situation. He went on a small wall, like 100 meters apart, and he observes the situation and tries to find out if this is a distribution problem. So like the man was in a blind spot, or people weren't reading the message or seeing the person, but it wasn't. So many people, he was in a good spot. So people were passing by, they were reading the message, but nobody was giving coins. So they were kind of indifferent to the message. So what he does after 15 minutes of observation, this is a true story, he comes back to the mall and he invests the €2 coin to buy a big blue marker. He comes back, he goes to the man, takes the label, turn it on the other side, and he writes on the label, today is the first day of spring and I cannot see it. He puts back the label in the hands of the man. He looks at the people passing by, and the head of the man gets full of coins in like a few minutes. So that is how words can change the behavior of people. And this is why, if we are relationship scientists, we cannot ignore that in every relationship that we map, in every human communication, there is a textual component usually. So it can be in email networks, it can be in any other sort of, even our communication relationship. If we map a social network, we can do it in many ways, but I'm still communicating with you. And so we could transcript the text and analyze it. So this is what we do here. We combine networks with words, and more specifically, we will apply social network analysis methods on networks of co-occurring words most of the time. So among the, one of the main indicators included in the app is this one, is the semantic brand score. It's a metric that I developed like 4 years ago, and which proved to be very fruitful for a large number of analyses. So I will briefly discussing what this is, but the app doesn't only calculate the semantic brand score. It does text mining, and it is an alternative also to many other apps. So you can use it your own way, but the way its name, the name of the app is SBS BI, so Semantic Brand Score Business Intelligence. And it is designed so that the main analysis includes this indicator. So this is an indicator originally conceived for marketing. So it's an indicator of brand importance. But indeed, it's just an indicator of semantic importance. So it can be applied to any word or set of words that you could find of interest in the text. I will give you examples, but what I mean is that you can use it with the names of political candidates, for example. You can use it with brands like Pepsi was Coke, but you can also use it with more abstract constructs like made in Italy. And so you might have a dictionary or a set of words identifying made in Italy, or I don't know, you could have a dictionary that identifies cognitive improvement. And so you can treat that elements as if they were brands. So, I mean, it can be applied in any field of text analysis. It doesn't have to be connected with marketing. The indicator is made of 3 components. I don't know if any of you is familiar with social media marketing and monitoring and all these companies offering consulting services to many firms. And what they measure usually is the number of mentions of a brand name. So how many times the word Coca-Cola appears in the tweets, right? That is one component of our composite indicator. So it's prevalence, which measures the frequency of a brand name in a discourse, how frequently it is mentioned. In our opinion, this is not enough. Okay, so because I could have 1,000 tweets that say, I love Pepsi, and they repeat all the same message. So the frequency of the name would be high, but still the message around the brand would be pretty naive. Okay, and so the image of the brand, which is its associations in the consumer mind or in the reader mind, would not be good. So I could have a lower number of tweets about Coca-Cola, for example, 600, let's say, but with a rich discourse around the brand. And so we have the second component of the indicator, that is diversity, that it's really about the richness and degree of uniqueness of these textual associations with the brand. So you will discover in a second that while prevalence is just a count of frequency, for diversity and connectivity, we need to use specific metrics of network analysis. So this is why we combine the two. And then connectivity, because I could have a rich brand image, but this could be, let me say, like if I'm talking communications about communication sector and industry, I could have a brand that is frequently mentioned and it has a rich image about the optic fiber, for example, but it's not mentioned with regard to the mobile offer or to phone associated with the commercial offer and other sustainability and other topics of the main discourse. So we need connectivity to evaluate how central is the brand in terms of brokerage power. So how central the brand is with respect to the full discourse, okay? So the semantic brand score, it's a composite indicator made of these 3 dimensions, and it can be applied to the analysis of big textual data, which means that you can apply it even to small data. But if you have 10 interviews, maybe it's better that you read the 10 interviews, but if you have 50,000 tweets and you want an answer in half an hour, as they often ask me, then it's better if you go with automated methods of topic modeling. We will also look at that. So it's cheaper and faster than surveys, and sometimes it's more representative for another thing that is about measuring honest signals. So, I mean, all my work in social network analysis has been about measuring honest signals. And so when you go to a customer and you ask if they remember about the brand Coca-Cola and if they remember the color red when they think about Coca-Cola, you are already introducing several biases, because from the one side, you know that they are being measured. So they know of being measured, so they have that bias. And also some associations with the brand are not spontaneous, so they can be induced by the interviewer, right? Here we try to look at the discourse of consumers, for example, when they post on social media, or we consider other stakeholders like journalists, and so the media. We can also use this kind of analysis if you make traditional interviews and you have like open questions at the end where people can speak freely. So we can analyze that part. And it's okay for multiple languages. So you will find already multiple languages in the app. Yeah.
So with social media, often the messages gets amplified by influencers. Right. So how do you deal with deliberate amplification by influencers of a brand, which in a way is distorting, making people feel generally of the brand?
Yeah, so we combine it with social network analysis usually. So we have metrics to identify influencers, and so we can either decide to include or exclude them, because sometimes, let's think about vote intentions, right? If I have to decide who to vote, I would leave the message of influencers in the analysis, because people don't care about the source, okay? They just receive an amplified message, and this message can influence their vote choice. So in some cases, it is good to leave it in. In some other cases, we want to do another kind of analysis, and then we remove it from the data set once we have identified them. Or, for example, ignore retweets when there are many retweets. I don't know, we can filter the data set multiple ways. Yeah. Okay, so we believe that surveys are useful, like focus groups, for example, in marketing research, but they cannot be the future. And even here, I remember when I got convinced about this idea, which I already explained, but I got thrilled by this citation that says, if you want to know how the lion hunts, you don't go to the zoo, you go to the jungle. And so this is what we will try to do with these techniques. The problem of some big data methods is that they are not theory-driven at all. So they come just from empirical research, while we thought it was important to ground this kind of analysis that we do into existing literature. So the indicator and the analysis are something new, but they are also grounded into existing studies. And so, for example, if we refer to the brand knowledge model by Keller, we see that he says that the equity of a brand comes from its awareness and image. So the awareness, it's about how much people recall and recognize the brand, and we try to capture it with the prevalence component, because if nobody writes about a brand and nobody reads about the brand, then it won't be remembered and awareness will be low. But then a brand image, that is the second component of brand knowledge, is also about the associations with the brand. And this we capture with connectivity. So we look at how strategic these associations are, and with diversity, which looks at their richness and uniqueness. We deliberately exclude favorability, and we keep it as a separate indicator for a number of reasons. The first one is that if favorability is calculation of sentiment, I mean, I'm just back from another conference where like 50 different people were showing their different measures of sentiment, right? And this is rarely deterministic, and this is rarely perfect in the results, and it's context specific. So here we have a deterministic indicator that once you decide the parameters, that is the number. With sentiment, we have an error that we don't want to include in the main indicator. And also we find that sentiment is not so much important in many forecasting studies that we do. So I'm not saying we ignore sentiment. The app will calculate sentiment, will calculate emotions, will calculate a lot of stuff related to the language, but it's not included in the composite indicator. So the process that we will also do together is that you basically have or collect some textual data. It can be, if you have a customer service, it could be tickets of the people writing to the customer service, or it could be emails, or it could be news or posts you download from social media. The app is not focused on downloading data. Okay, so the only option to download data from the app at the moment, it's Twitter. So you can definitely use it in a simple way to download all the tweets you want, but it doesn't include other tools. But I can give you suggestions on how to get data, news data, for example. So the focus of the app is on the analytical part. So once we upload the collected data, what we do is we pre-process the text, like removing punctuation, stop words, and all this kind of stuff. We tokenize the text and do all sorts of pre-processing, also depending on the task we are working on. So for example, for the semantic brand score, there is less cleaning than for the topic modeling, which works on more simplified networks, right? But the main step is when we go from texts to networks, okay? Because in that part, we really generate co-occurrence networks and use metrics that makes the difference with respect to traditional approaches. So here is an example. I have this sentence that says, Aurora was bright as the dawn, and yet she was mysterious and dark as the night surrounding the stars. So from this sentence, I would remove the red words because I consider them stop words from the English dictionary. So they add little meaning and content to the sentence. I would keep the blue words and stem them. So stemming, does everybody knows stemming? Yeah, no. Okay, so it's the removal of word affixes. So for example, I have the concept of beauty, which in Italian could be belli, belle, bella, bello, okay, which is for plural and singular and male and female declinations, okay? So we just remove them with specific algorithms because we don't want the word beauty and beautiful to be in different nodes of the network because they represent the same concept. And so we do stemming or lemmatization, yeah. Yeah, because depending on the language, so here, the idea is that we work on big data. And so even if you have a slight percentage of error in the construction of the network, it's not a big deal because when you have, I don't know, at least 20,000 words and so 20,000 nodes in the network, because each node is a word or a concept, then it's okay if they are not so much matched. Also because if they represent the same concept, this will reflect into the structure of links. And so these are weighted networks because the more times two words co-occur together, the stronger the link between their nodes in the network. Yeah.
Just from a practical point of view, I find that with word stemming, it makes a readability quite hard.
Yeah.
And so what I've done in the past, and I don't know if you've tried it, is actually the substitutes. So you use a form of word substitution. So for example, beautiful.
Yeah.
Instead of beauty and all other synonyms or versions of it, you just say, right, I'll just use the full word beauty or beautiful, just to make it more readable.
Yeah, this is already included in the app, but it's an important point. So what I call it reverse stemming, right? So we do stemming for the processing, but when the app generates results and the final reports, what it does it follows a probabilistic approach. So if the node beaut represents both beautiful and beauty, but I add 90% of times the words beauty and 10% of times the word beautiful, then the app will substitute with beauty. That is the most recurring word for that node. And so you will have readable results that are even better than otherwise we have. It's complicated to read the stemmed words. Yeah. And then you can configure different threshold windows. So we build networks by co-occurrence, and you can choose the maximum distance of 2 words in the text in order to define a co-occurrence. I think the default is 5 words once you remove the stop words, but you can choose from 1 to more, okay? Sometimes it doesn't make sense to put very high values. What I show you in these 2 graphs is that usually SBS results are, however, pretty stable, regardless of the co-occurrence threshold that you pick. So if you go 5 or 7, it's usually good. Also depending if these are tweets or if it's a long text like a news. Okay, so the theory about this, it's almost finished. I already anticipated how we measure prevalence, so it's just a frequency count. How do we measure diversity? This is more interesting because we use a metric, a new metric of centrality, and it's distinctiveness centrality. So this metric, it's similar to degree, but do you know TF-IDF, that logic? Term frequency inverse document frequency. You do, but it's new to the others, I guess. So when I'll tell you about this, because this will also be useful when we extract keywords, right? So I could have, to identify keywords, some people look at the frequency of appearance of that keywords in the text, but I could have a word that is a stop word, like the word "and," that will appear in all documents, right? So it's not really a keyword, it's just a stop word. So in textual analysis, we do not only consider frequency, but we also penalize this frequency by a logarithmic terms that tells us if this word is appearing in all the documents, then just drop it. So the best words are those who appear very frequently, but just in a subset of documents. So that is gonna be a keyword that it's able to distinguish among documents, right? So with distinctiveness centrality, this is a new metric where we translate the TF-IDF logic that is traditionally used for textual analysis to network analysis. So we say, I'll give you the example with these 2 nodes. Let's see if I can get a pointer. Yes. So you see node number 1 and node number 2, they both have a degree of 4, but according to distinctiveness centrality, node number 1 is more important than node number 2. Why? Because node number 1 is connected to nodes 6, 7, and 8, which only have that connection. Whereas node number 2 is connected to other nodes that share many other connections, right? So it's these associations to the node are less distinctive because are shared among many other nodes in the network. I give you a couple of examples to clarify this. So let's say we did a political analysis, Biden was Trump. Okay, both of the brands of the political candidates were associated to the word elections. So this would count as an association, but it doesn't really make a difference. This is the problem because it doesn't change people's words in vote intentions, right? If they are linked to the word elections. Well, on the other hand, I could have links to other words like Olympic Games or Ukraine and Trump impeachment and that kind of stuff that could change the vote intentions of citizens. So we want to value more that associations that are with peripheral node or less connected nodes. It's like if you, this can also be a directed measure. So one question that I could ask you is, imagine you receive, you are here and you find, after the break, we will have a break soon, you find a love letter below your laptop. Do you prefer receiving that love letter by somebody who writes love letters to everybody at Sunbelt, or who writes just to you? Probably just to you if you don't like competition so much. And likewise, if you send a love letter to somebody, you would prefer to send it to a person who only receive it from you and not from everybody else. So this is the logic of distinctiveness centrality. Less shared connections are valued more. And then connectivity is easier, fortunately, because it's weighted between a centrality, which I think we all know. So it considers the arc weights, the inverse of their weights, and C is the brokerage power of a brand node. Well, and then we put these things together by standardizing the indicator because they have different ranges. And so we need to build a composite indicator. If you are fan of statistics, you will have like 300 different ways of standardizing the indicators as an output of the software. But if you are happy with the two most common, I will have a reduced file for you. You get both from the results. So you choose the painful way or the easy way. Okay. Do you have questions so far? Any questions?
So you just described the three measures.
Yeah.
So the really unique part that you describing is that distinctiveness of gravity.
Yeah.
Using sort of a modified version of the frequency.
Yeah. Yeah, but also the good part is also putting the three measures together, because we also show that if you use them separately, it's a different result. And for example, it's not so well performing with as the combined indicator. So it's the theory behind building a composite indicator, and then the metrics are, distinctiveness, it's more new than the others, but it's also why these and not others, and why do these work together. And often I also get a question that is, oh, but they are very much correlated, so they measure the same thing. But it's okay, because when we build a composite indicator and they underlie the same construct, that is, for us, it's brand importance and memorability, then they should be correlated, but not exactly 100% correlated, because still, like degree, betweenness, and closeness, okay, they are different metrics. They are, of course, correlated, but you can use them to capture a different side of the information. So I will stop myself very soon, and I will leave the stage to Francesca, who will introduce some case studies. But before doing that, I want to show you just very briefly some possibilities that the apps, some analysis that the apps allows you, apart from the calculation of distinctiveness, centrality, and other metrics like rotating leadership. It's another new metric of social network analysis, and the app calculates it for you. But okay, so why do we use all this stuff? Well, this is the most traditional use. So we may of two competing brands, for example, we measure the semantic brand score and we track its evolution over time. So here I have Telecom, which is the incumbent in telecommunications in Italy. And this was a rebranding operation. So they decided to change their brand into TIM. And this has started just a little bit before the beginning of this graph. And so they asked me to track how much successful was that rebranding operation in terms of marketing and communication. And with an indicator like the semantic brand score, we can measure this quantitatively and say how they are doing, also compared with other brands or competitors. So this is the main graph, the first graph that you get from the rebirth, and it's, the most straightforward. Likewise, this is a Twitter network, and sometimes you do an analysis on Twitter and you have brands on Twitter, and you immediately notice that brand C, sorry, is the most important compared to brand A, which is the second, and brand B, but you need to quantify this gap of importance, and you also need to, to provide recommendations to the companies, right? So you want to say, or to the policymaker or whatever, but you want to say, what should you do to improve the relevance, the importance, and the memorability of your brands? And so you can track prevalence, diversity, and connectivity of different brands and give recommendations. So for example, if prevalence is low, you should recommend influencers or your press office to talk more about brands. If diversity is low, you should connect your brand with different topics and make the image richer. When connectivity is low, you should connect your brand with more strategic associations. And this can be tricky. So the software also gives you some tips in these regards and tells you which are the words with the highest connectivity. And now we are also extending the app. I have, a beta version, but it's not yet integrated into the main app because it simulates this new addition. What are the words that best can improve your connectivity? So you will have graphs of the 3 dimensions, and you will have positioning graphs. So for example, in this chart, I have brand importance, that is the SBS on the vertical axis, and sentiment on the horizontal axis. So I would ask you, if you were to own one of these companies, which one would you choose? Okay, so this one. This one, any, okay. Yeah, I definitely agree with you, because sentiment, you see, it's in a positive range and with a small variation. So values above, depending on the scale, but positive values here mean positive sentiment. But if you were to pick Ian, it's so little importance of the brand that it has a very little value, whereas Enel and Eni are the incumbent in the utility market in Italy, okay? And as you see, they have the highest brand importance, whereas sentiment, it's a little bit lower. So we can assess brand positioning. These graphs that you see on the slide, you will see them also dynamically evolving over time when I show you the app. Then the app will favor the study of the brand image. So once we have all these beautiful numbers, I'm an engineer, so sometimes I get in love with numbers, but then we need to make sense of them. So the app will also allow you a mixed method approach and a qualitative analysis to make sense of these numbers. So we'll give you information about the brand image, for example, distinguishing between shared associations and unique associations, which are words and concepts only associated to one brand and not to the others. It will measure brand similarity. So when we talk about a brand, and when we deliver an image of a brand, how similar are these two brands? For example, here I have the primaries of the Democratic Party in 2019, and we had 4 main candidates, Biden, Buttigieg, Sanders, and Warren. And you see that Biden, that is the one that won the elections and at the end, was the one with the more distinctive image. So in this graph, you should only look at the distance among points. So you see that Sanders and Warren were the maybe most traditional candidates, and are very close, so very similar in the image. Biden was more connected to Trump and to other, to other things that were happening in that specific week. Where Buttigieg, he was, carrying out a slightly different political campaign, and he was the first, I think, candidate who was openly gay. And so the image was still disconnected from the others, right? So we have these graphs of image similarity. The app will make an analysis of the dimensions of the brand image, and you can also define your custom dictionaries. And if you have a lexicon or a dimension of interest, you can define your own dictionaries. The app can also be used to clean textual data or to extract keywords for general keywords or for the improvement of connectivity. I will show you how to do network topic models. So we will use clustering algorithms on semantic networks and extract topics, which are clusters of words. And we defined, I mean, me and Francesca, we published a paper together on this to show that there is a pretty simple formula that it's based on weighted degree that will tell you what are the most significant words in each cluster, because each cluster, it's, I don't know, around thousands of words, but you want the top 20 to give meaning to that cluster. And we see that with these methods, interpretation, it's pretty easy. So it's not like LDA that you have multiple words in multiple clusters, and sometimes you have things that are very strange to combine together. You could have some noise in this analysis, but usually the first words that you get give you an immediate idea of what is the topic about. And then with the app, you can measure how much each brand is associated to the different topics, and what is the relevance of each topic, and what is the strength of connections among topics, okay? Because they are, of course, not independent from one another usually. And what else? The last part is that you have a set of extra functions where I try to include what I found in the literature, and I'm still including stuff, but sometimes I don't want to switch among many different software, right? So the SBS BI was born to do this kind of analysis that I've showed you so far, but sometimes I want to calculate things that are calculated in Luke. I don't know if you use LIWC as a software, or you want to use a lexicon for extracting emotions from the text, so happiness, anger, disgust, joy, and whatever. And so it has a function that we call text analysis, which will calculate like 300 variables that usually you need several software to do that. So it's not our main part. And of course, we just do not copy the dictionaries from the other softwares when these are not open source. So there is a modified version, but the results that you get is mostly that one. Okay, and then as the very last part, it does network analysis. This is not new to you, so you will use your own software for network analysis. The advantage of this software is that it can calculate specific metrics that are not well embedded in other software, like so distinctiveness centrality is calculated with this software, rotating leadership, which is the oscillations in time of between the centrality, which we find connected to many other measures. And it also does network and text similarity. Okay, so you can build networks based on discourse similarity, for example. And so these are the main functions, or the rest is pretty standard. And the formats is the one of Payek. So you can put as a format Payek networks and it will read them. Okay, so now I'm going to ask you, it's 3 p.m. So we spent an hour together. Francesca will introduce the case studies, and then we are finished with theory. And we start with the tutorial. Do you want to listen to her for like other 20 minutes and then we take a break, or do you want a break now? And then, I mean, do you want a break before the tutorial or immediately if you're kind of? Yeah, okay. So we listen to her and then we take a break, relax a little bit, and then we start with the practical stuff. And I already created an account for the groups and for all of you. Even if you don't know, I will give you the credentials in a moment. So I would happily leave you the stage, Francesca.
Great.
So
thank you.
And you just say next so I can push
Perfect,
forward
yeah.
the slides. Yeah.
Yeah, I think it's simple this way. Again, hi everyone again. We have selected probably way too many cases, Andrea, I have to say, and so 20 minutes. It's I'll try my best. I'll skip, and I'm glad that you also mentioned some of these.
Half an hour, all the time that
It's
you
okay.
need. Sorry,
No,
it
it's
was
fine.
just not to scare them, you know.
It's fine. No, that's okay. No, and I'm glad you also mentioned. So we wanted to start with example from political brands, specifically because, and also historically, if you think about the history of the semantic brand score, that's what historically I meant. We use this to check the how robust the indicator was, and and whether the indicator, the SBS, was more predicting than its components, the three components that we just learned about. Please, next. We started with Italian political elections. So looking at 2016, 2018, we collected data from eventregistry.com, which is a website that gives you access to online news, newspapers, blogs. And some of these elections were people had to the binary choice, because there were referendums, like it's a yes or not, and others where they had to choose among multiple candidates, 4, 6, sometimes 8. And then for the case of the municipal election in Rome, we could test the semantic brand score, comparing the outcomes when there were many brands or when there were only 2 brands. When we say brands, in this case, we were considering the political leaders. So let's next, please. So in this case, so this guy here is for I don't think we have Italians in the room, but is the former Prime Minister Matteo Renzi. And this is the case of the Italian constitutional referendum. Just as a context, this became basically an election on Renzi himself, because it was a major reform that it was put forward by this political leader, by Renzi. And so, I mean, he lost. So at the end, so we could say that it was the brand was all about him. But anyway, so the reason for including this is because we noticed that by comparing the average data from the polls with the SBS over the last 2 weeks before the elections, the prediction error was 1.6% for the SBS, and definitely higher for the polls. But we also found in this same case that the semantic brand score was a better predictor, as a combined indicator than its components taken separately. Just, I think, as Andrea was mentioning before. So here, in this case, we have, as just mentioned, we have used the SBS to analyze the importance of brands represented by all these major Italian politicians who were running for the general election in Italy. You guys know that we have a lot of, you probably should know that we have a lot of elections in Italy. We had probably well, in 50 years, we had almost 50 governments. So we have a lot of elections. Our governments don't last very long. So we had a lot of data that we could use. And that's why we started a lot with these cases. So anyway, so even in this case, you can see that the forecast error was higher when we compare the 4 candidates, they were running during the first round. In the second, I think, anyway, I'll stay here. So the SBS had a relatively high error, 19.76, but still lower than the polls. I'll go next because you can see that the error went down when we were comparing fewer candidates, as in this municipal election for the mayor of Rome. And so we, I think the main, probably next time we should put this all together, because this is the same election, but when instead of 4 candidates, we had 2, we see that the error goes down. So the SBS forecast is definitely more informative, though it's definitely lower than the poll. So in general, we can definitely say that by comparing all these different elections and comparing the brands, these political brands, which are represented by the politicians themselves, we demonstrated that it's better to use a semantic brand score than polls. If you also consider that polls are less, at least in Italy, I'm not really sure in many other countries all over the world, but definitely in Italy, you're not allowed to do polls right before the elections. So using the semantic brand score is a good option to see trends in terms of the brand importance, in this case the politicians. And we also noticed in one of these cases, for political elections, that the brands represented by the political leaders was even more important than the brand represented, at forecasting the outcomes of the election results, was more important than the party itself. So in a way, you can read that as the fact that the value of the value of the personality, right, that is associated with the political brand / the leader. It's so people vote for the candidates rather than for voted for the candidates rather than for the party. And that happens everywhere. People vote for somebody they really like, even sometimes if they are Republicans, if you are in the US. Today, with this, it will be interesting to see, but it's a different realm. But with the polarization that we are seeing today, it's definitely more something that will be interesting to test again. But at least in this election that we saw, people were people were attracted more by the leaders than the parties. Next, please. All right, so this is just a summary. So what we learned with this case is that we learned that the SBS is definitely a good offer a good approach for when we're looking at political elections and the outcomes of political events. And that analyzing 30% of the news is enough to predict brand success. There are some limitations, of course, and one of the main things is that you need to make sure that you're using the most informative data sources that are specific to the particular phenomenon. In this case, you need to use the most informative, correct, and comprehensive online articles and blogs. So choosing the right data and the most comprehensive data is key to have good results. For the future, especially referring to the studies that we have shown before, would be interesting to test the approach within other countries, and that's what we will show in a second. and also weigh the various data sources to understand the impacts on the outcomes. So we wanted to, we with the next slide here, we went and we checked, okay, we were focusing on Italy. As Andrea showed you, it's not about the language because the app can, analyze data in different languages, but let's also take a look at the same phenomenon of the political election, the political brands, but in the US. So this is just work, just a representation that you could use also, you could get from the app that shows the most frequently discussed concepts in the online discourse around the Democrats primaries in 2019. So we had, just as a context, as a reminder, so we had, as of November 2019, we had 18, I think, 18 candidates that were seeking the Democratic primaries. And we chose only the top 4 candidates. I think you can go to the next one. The top 4 candidates that were, they had a vote share that was higher than 5% in the last available national polling. And these were Joe Biden, Elizabeth Warren, Bernie Sanders, and Pete Buttigieg. I'm not going to go into details because Andrea mentioned them before. So when we looked at these, the major top, I think you were showing here before, right? This, so here you see the topic modeling graph that indicates the main topics and which is closer to each brand. As you can see, Biden is mainly embedded in a cloud of words like T1 here that is separate from the clouds where Warren, Buttigieg, and Sanders are. The 3 of them, and as we all know, Biden won the primaries and then won the elections, but in this case we are talking about the primaries, right? So Biden is also reported in articles that are associated with a concept like impeachment, hearings, testify, ambassadors, which in that makes definitely sense because there was, in that period, there was the Ukraine scandals that involved his Joe Biden's son. And also there was the hearings were connected with the Trump impeachment process. While the clusters, in which the other candidates were embedded were characterized by words associated with the primary votes, like campaign, candidates, very, very, not very rich. And actually you can see that probably in the next slide. Okay, I think I had, but well, anyway, what the, I mean, I thought that we had another slide, but that's okay. Where you can see also that there is another, the trends, but I think we had in the previous version. So
yeah, I think it was before, right before, it was the bar chart where we were showing the associations of brands with.
Oh, you were discussing it before.
It's not repeated here because it was taken from the same case study.
Yeah, it makes sense. But the reach, it's just, I want to say that the richness is definitely another element that differentiates the so anyway, with this we're looking at how you can see how in the Biden's online discourse the articles referring to Biden's are more they discuss more about power and authority, and they're connected more to past events. So there is, definitely was really hard to compete with in the online discourse with Biden, and Warren, Sanders, and Buttigieg as brands were really having a hard time differentiating themselves because the history was not there. There was not a lot to talk about, and definitely the online media was already moving to see Biden as a potential candidate against Trump, and then so there was a more rich discourse that was surrounding than the winner. So I think we can go next. So here I mean, the one thing to say is that this shows that the complexity and the informativeness, which are two indicators you can get from the app. So the complex and informativeness of the articles where Biden was mentioned, is another indication of striking differences. So probably because in this period, again, the online discourse was centered around Biden's son's involvement in Ukraine, and the lexing is kind of repeated on the same concepts, where all the others like Warren, Sanders, Wood, they were talking about healthcare, voting rights, racial justice. So they were fighting around more diverse and more concrete topics and agenda points, while Biden was kind of less informative in the online discourse. It was stuck around always the same and 2, 3 areas, but nothing distinctive. So anyway, so if you want to go to the next one, I think we are kind of done with the political brands, right, in the political discourse.
Yeah, sometimes less is more, right? So this is why less informative and simpler message that got the citizens' attention, and also because the message was more redundant. So appearing in more news was less informative on average. Yeah. Mm-hmm. So let's see, but maybe this one we can keep.
Oh, I mean, I could just say a few words here because it's just really just the context, just as a transition, because the semantic brand score, now we want to use it to also study the organizational reputation, which is an important concept in management. And we know we're going to analyze how we're going to use the SBS within organizations and how they are and how organizations are represented in the media, in the general audience. But this slide is just to say that there is a big difference between being known for something good, being known for something and being known for something good. And the reputation, and SBS can really help because the reputation of an organization is rooted in their past, is rooted in their historical behavior, but it's rooted also rooted in the present association with controversial decisions. So if you're want to go to next, so just to show that the SBS is able to map to map the organizational reputation from in terms of the awareness of a specific company, but also the relevance to the audience and the positivity and the negativity of the reputation through the sentiment analysis. I mean, it was just to say that as an introduction to, I guess, the last part of the cases, right? So in my version I had okay, but it's okay. So this is fewer is better. Anyway, so this is one of the newest cases where that discusses the firm brands, family firm brands, where we looked at 63 out of the 100 most known entrepreneurial families and their businesses. So we looked at about 53,000 online news published in 2017. So what is really interesting that the family, for the importance of a family brand is definitely associated with increased revenues, but we didn't find an association with the sentiment analysis, which is actually a common result that we keep on finding. And it's almost to say what's important is to talk about something, but not necessarily in it doesn't matter in a positive or negative way. We had another, I don't know if it's the next slide, regarding the tourism forecasting, or we removed it.
No,
Yes.
it's just maybe I reordered them just to make your task more complicated, you know.
That's okay. I just that I had, yeah. Remember, it's
But I can go to tourism and then come back.
no,
to
that's
this
okay.
other
No,
one.
that's okay. I mean, I just in my mind when I was
Yeah.
looking at the family fare brands and the tourism forecasting, even in this case, we found a similar result that it did not really matter how positive or negative was the connection between what people were talking about online and in this case, how many people were entering museums. So in this case, just to go in order, we were looking at how many museum visitors, 5 different European museums had recorded. So we definitely found that the semantic breadth score with the indicators was, and so the way people were talking about these museums online was associated with the number of visitors. So it was a good predictor of the number of visitors. But it didn't really matter how people were talking about in a positive or negative way. So what was important just to create a buzz, to create curiosity around a brand, in this case, a museum. And that was enough to attract the interest of the tourists. Now, sorry, I don't know which one you want to go. Okay, so this is one of the newest one, right? That's yeah. So that's in this case, when we analyzed that we looked at the SIVC, which is the social impact venture capitalist, and we looked at how they were communicating on their website. And we found that there were different with different categories, right? Where we different categories, different categories of delusionists and naive dreamers, blabbers, smart heroes. So they so we basically by looking at so by looking at the way they were communicating, they were using specific terms like social impact and the different synonyms. Well, we were able to identify different different categories of investors. I don't know if you want to say more about that, but Andrea, about this, because this is one of the latest one that.
Yeah, this has been published yesterday, so it's pretty new.
Yeah.
I will also cover it in my talk, but it's here. The idea is that we use the SBS to assess the social positioning in the communication of these investors. And so the brand is a set of keywords indicating how much they stress the social side of their investment. So that is the one part of the positioning, and we use semantic network analysis, and the other part is how much they differentiate the language from the mass. And so we make these 4 categories, and also we study the topics. I mean, it's unreadable, but it's down there. So the topics associated to these categories. And in the end, we discovered that depending on the category and on the topic that they cover, those that are the smart heroes, they get more investors' attention, okay, which we track through Alexa rankings. So you see the smart hero bar, it's lower because it's lower in the ranking. So being the first would be the ideal, right? So the lower, the better. Yeah. And so, okay. This one is fine, or? But you are muted.
I'm sorry. Yes.
Okay.
I think we're at the last few slides, because this is another case where we're looking at, we're using the semantic brand score to measure the importance of the company's core values. And so we looked at 58,000 tweets that were written in Italian by more than 26,000 users. Just to see, when we talk about big data, that's a lot. And we found 5 different categories of stakeholders that emerged from the analysis, like employees and the company communication teams and media association. but anyway, the main result here is that was really surprising is that the corporate social responsibility was far less relevant to stakeholders than we would expect. And so most of the attention was, the importance was mostly, the importance went to other concepts related to operational excellence, so there were, unfortunately, there was the values, as was less important associated to corporate CSR and corporate values than we would expect from stakeholders. So this is, just one point in time. I think it's just yeah. So we just unfortunately, and associated with what to a trend, associated to a trend that definitely should change. Anyway, so I want to go forward because we have way too many others. So yeah, for example, I can't really spend too much time here, but just to say that the SBS has been used to look at the brand importance and how it impacts the fluctuation in the stock market prices. And we also analyzed it to predict the consumer confidence index. This is specifically related to the Italian consumer confidence index by you can find all the papers on the websites that have been published, so you will find that. And next one, yeah, I mean, these are just to say that you can use this. Yeah, thank you. Just to say you can use this to compare. For example, if you're working for a company, you can use the semantic brand score in the app to compare the brand image of your, your CEO, your boss, and people who represent the company, and see who has, the relative importance, and maybe choose the right, personalities to drive to draw a comparison. Or the next slide, it's just to say, if you're an entrepreneur and you want to start a company, you can use the app to look at data sources, and if you want to start a company in a new market, for example, that can be useful to see how should I name my company? What are the concepts associated with with that name? We all know, and just I will close here. We all know how many. I mean, there are some horror stories of products and brands named that have been really non-successful because when moved to another country, the meaning of that. The meaning is really, the connotation is bad. So anyway, so this is a tool also to explore, if you're an entrepreneur, a way to, what name to give to your product, what name to give to your company, and where to move. What are people, thinking about in a new market. So I will stop here. I think that should be the last one, right? I don't know if you have new surprises for me, Andrea.
No, no more surprises. And I would like also to stop with this image because, food is important for us Italians, right? So I won't reveal the solution here, but it's a case study that we could also, if we do not download new tweets, I have these tweets for you. And so you could work to tell us what is better to promote if you open an Italian restaurant abroad. What in your advertising, what you should put your attention on promoting pasta, pizza, or ice cream, what is most appreciated by people who are not Italian. Okay, so thanks a lot for your participation and for Francesca's presentation of the case studies. I think we all deserve at least a short break. I would say 15 minutes break now, if that sounds good to you. I will stay here for questions, and I will close the slides that I will then share with you. And I want to put a notice that I don't know why they change our room. So we have a break now. We have a break at 5 because we need to switch the room. And at 5, we will have maybe a little bit longer break if you want to look at the elder Aborigines that are downstairs. And then we will keep going from M5 after the 5 break. Okay. And so also people attending online, I've shared another Zoom link because also Zoom is going to change. Okay. So see you in 15 minutes. Thanks a lot.
Andrea, I'm going to put the link to the other Zoom in the chat, okay?
Yeah, sounds great. I don't know if there were other people, or let me, okay. So, do you have any questions so far? Because otherwise what we do is we move to the app finally. So we start using it. I will share my screen again. Let's see if it works. So this is a server-based app. So in order to use it, you need to use one of our servers, and the accounts that I have created for you are on these servers that you can access on bi.semanticbrandscore.com. So I have created an account for all the workshop participants that will expire on 31st of December. So you are free to use the app up until then. The account, your username, if you want to try it, it's the initial of your first name, 2 initials for people who have 2 first names, and then your surname. For people who have 2 surnames, just the first one. Okay, I am one of those, so I understand. And the password, it's SBS, written in small letters, 2019, written as a number. So I will now log in with my account. And then I have also group accounts if you want to work in groups. And it's good because you can access the same account from multiple PCs and all work together on the same. And so the app, it's not free for commercial use. We don't release it for commercial use because for companies, we sell reports and not give the app access. But if you want to use it as a scholar, you are free to do that. So if you want to use it and your account is expiring, just send me an email and I will renew it for free. So there is absolutely no problem. Or if you enjoy it and you want to partner in research, we are always open to do projects together. But even without that, I mean, of course, we are happy if you cite the metric, but it's not even mandatory. Okay. So this is the basic structure of the app. It has an account menu that it's pretty useless. It's if you want to change the password on your main account, that would be nice. But apart from that, it's just for logging out and changing your email. It has a documentation menu where you find the references of the theory supporting this software, the terms and conditions, but there is a documentation link that's, and I mean, it's being constantly updated. It's not a real full manual, but it gives you an idea of the app's main functions. So if you forget something and you don't want to watch back the video, but you forget the meaning of a parameter of the app, you can look here and also look at the structure of the app, which has a data fetching function for Twitter at the moment, or you can upload external data. And that what you do afterwards is you validate this data because the app wants the data in a specific format. And sometimes there are errors or people write with strange characters or the text is encoded in the wrong way. So we have a validation function that should reduce the number of errors in the data input. And then you can do a bunch of analysis, setting parameters. You will see that there is a menu for a main analysis and reports, which does SPS calculation and topic modeling and all brand analysis of the brand image. And then in every function, you can download results, and sometimes you also get graphical reports. So that is the structure. So going back to the app, you have a fetch menu where we will see the Twitter function. I had more, but these people from Google and Facebook are always changing things. So it's hard for us to keep up with their changes, right? So for now, we keep Twitter. Then you have an input menu where you can upload and validate the text file. You can a menu for generating parameters, a menu for the analysis, and then you have menus that we will see later that are from extra analysis, like calculating the emotions in the text for the text analysis, or generating word clouds and extracting keywords, or if you want to play and analyze networks, so you can calculate between centrality, but also distinctiveness, rotating leadership, and other metrics. So this is the basic structure. So I will now go step by step. So the first thing here is that you can use the app to fetch tweets. You should have the Twitter API. So how many of you do have the APIs? Okay, so half of the room. Okay, sounds great. So you just need the bearer token and you copy and paste it in the app. So when you first, with your account, when you first click on Twitter, it will ask you to put the bearer token there, and it's everything that you need. So once you put it, then it's there forever, unless you click on change API keys, but otherwise it will stay there. And then, I mean, you can do even more complex queries on Twitter, but this is deliberately simple. So if you want to do more complex stuff, you can also use other apps and then upload the results on the SBS BI. But what we do here is we allow you to use the premium or the standard API key. As researchers, you can all obtain the premium API access, which give you access to tweets from 2006 and much more tweets. So I suggest you to upgrade your Twitter request. There is a form to fill in to get that kind of access. And here we can set a query as we would do on Twitter. So we can define some examples together. What I always suggest is that you, before go on search.twitter.com, and you try the query here. And then once you find that it's the appropriate query and it works, you go back to the app. And so I don't know, do you want to do a test and search for something? Yeah, any idea about what to look for? The ideal would be, I mean, just for this example, because if we look for COVID, we will have thousands of tweets every minute. And so we don't have historical data, because with the standard access, you can only get data from the last 7 days, but up to a certain threshold. So if you finish the threshold in 1 day, then you won't have historical data. So it would be nice to have something that it's not so well discussed. Yeah. On the first page. Okay. Could you find out password again? So the first name is the username. Yeah, I'll write it here. So this is the password, SBS 2019. And do you remember me your surname? Yeah. Vassi. Okay, so your account would be J for Julia and Vassi for the, yeah. Oh, I found you on Twitter, by the way. Oh, yeah. Okay, so, and then you can change your password. So you also have your own data protected. Okay, so I don't know, any topic or?
So, I've got my own topic, which is very selfish.
Yeah, it's good.
So we're looking at the post-Bible discovery.
Mhm.
So we're looking at, so a few of us are researching plastic pollution on beaches.
Okay.
But we're also looking at advanced recycling of plastic, which is a very controversial subject in many parts of the world because it's recycling plastic, but it's also prolonging the use of plastic.
Okay. Yeah.
And so with the circular economy kind of thinking, the question is we should reduce plastic
Okay.
use altogether, and recycling plastic waste is not a good idea. So there's controversy there.
Okay.
So that's my one suggestion. Other people might want otherwise.
No, I mean, sounds interesting to me. So what kind of keywords would you use? I mean, because if I put plastic, that might be something. So we always get the tweets, all the tweets. So you should look at the latest tab. Yeah.
So in the Twitter searches I've done in the past, used the terms advanced recycling.
Okay.
And that look at plastic recycling, you get a whole lot. And then advanced recycling is chemical recycling of plastic, regenerating oil.
Okay, so just to show you something, if you want to, I mean, this might sound trivial to all of you, but if I want to look for exactly plastic recycling, I should quote this in the query. And otherwise, this query will find all the tweets that contain both the word plastic and the word recycling, because putting a white space on Twitter means putting an and operator. If you want to look for tweets that include either the word plastic or the word recycling, you should declare it in this way. So you should use in capital letters the operator or, okay? So if I look for this, I mean, this should include also advanced recycling, I guess, but we could make it better in this way. So we could say plastic and recycling, or, well, if I say advanced and space recycling, this would also be included, but maybe there are some people who write it all together. So I don't know if this makes sense in your case. Advanced recycling without the quotes. Does it make sense? I don't know. Or maybe there is an hashtag that we might want to include. So okay. So let's see what happens, right? So
the interesting thing going back to the brand is that companies that packaging.
okay.
So the companies that try to get rid of using plastic packaging are going to have a higher reputation.
Okay.
And more environmentally responsible.
Okay.
That'd be interesting.
Okay. And so it's here we have two choices, and this is an interesting point. So for example, if I study energy companies or telecommunication companies, one approach is I don't put the names in the queries, and I download all the news discourse about energy and or telecommunication, and then I study the strength of that companies without looking for their names. So I study them with the SBS, but the query is clean. The other option is putting the company names in the query in relation to a specific topic. And it could also be an option if your main goal is comparing competitors instead of looking at the strength of that company within the overall discourse. So I don't know if here we want to put the names or if you know. No, maybe we can look for them later on. So what we can do here is, so let me do this with another account because I have. Okay, I can use this query, and I could also limit the language to English or Italian or whatever I want, but I will do this directly from the app. So I go in the fetch Twitter. I click on change the search query. And so here I will copy paste the search query that I was using on Twitter. I will choose English as a language. And here I can specify a number of tweets that I want to fetch. So let's say I want to get the last 8,000 tweets about this. So I need to specify a time window. If I do not use the premium academic API key, I can only specify up to 1 week from today. So I can say, I don't know, 6 to yesterday, because today would be partial, right? So, and then it's easy. You just click on run. You see it has already, I mean, if you don't get strange error messages here, it means it's running. So you can either refresh the page or check the status. We need to download 8,000 tweets and it's already 1,200. So for other examples, I will give you pre-made cases because, for example, for the case about fashion that I will show you, the calculation takes around 40 minutes. And so depending on the case and on the amount of data that you want to treat and on the specific operations that you want to make on the text, sometimes it takes seconds, sometimes when it's a large data set, it takes longer. So here you see we already downloaded 8,000 tweets. If you click on downloads, you can open it with a software, which I recommend that it's Notepad++, which is an improved text editor, or you can open it, I mean, we just double click it and open it with Excel. So if some of you read in a bad way this file, so you find all the text in the first column is because you don't have the comma as a system separator in Windows, for example. And another problem that it's frequent, I mean, it's less frequent in the English language, but it's frequent in the Italian language, but we also find it here at this line, for example. I don't know if you can see it well. So we have some strange characters here, you see, because the encoding of the software, it's always UTF-8, sorry, whereas Excel, my Excel wants UTF-H boom. And so you need, if you want to work on the file with Excel, it's not necessary, but if you want to do that, you need first to convert the encoding to work on the file, and when you re-upload the file in the app, you should go back to UTF-H. I show you what I mean. It means that I should open this file with Notepad++, and so you see, where was the error? It was line 18, right? So you see there is this kind of symbol here, which is like a flower, like an emoji, which reads bad in Excel, okay? Because the encoding, if you go in the encoding menu, this is encoded in UTF-8, but in order to open it with this version that I have of Excel, you need it in UTF-boom. So this thing is very simple to do. You can do it with Notepad++. So what you could do is you convert the encoding to UTF-8 boom, you save it, and then I open it again with Excel. And now it should, you see the little plant icon here, so it reads well now. So this is, I'm just covering this because it's a common source of errors that you don't take care of the encoding, and each system in the world has its own encoding, so it's very difficult to standardize. So we use UTF-8, that it's pretty much the standard. Do I have, okay, no, I don't have questions. Okay, and so in the first column, you get the text of the tweet. In the second column, you get the date. So here we have tweets from the 6th to yesterday. Then you have a retweet count, like count, and the following, the number of people this account name is following, the number of followers, and so on. So you have all this information. Something that it's very important, we don't care about this information for the SBS analysis, or better said, you could manipulate the file and produce a file that has to be analyzed based on, I don't know, you want to only analyze tweets of people who have at least 1,000 followers. So you filter this data set and you give it as an input to the app. Okay, but the app, in order to work, only needs an input file that has, and this is mandatory, text that you want to analyze in the first column, a date in the second column, and then the third column is optional, and you can use it for weighting sources. So you could say that, for example, Repubblica.it, it's an Italian newspaper. You would say that an article that is appearing on the New York Times is more important than an article appearing on Repubblica. And so if you want to weight sources, you can use numbers in the third column to represent a ranking of the sources. I almost never use it. So the very mandatory is that you have text in the first column and a date in the second column. And the correct date format, it's not the one that appears on Excel, but it's this one. So you see you have 2 numbers for the month, then the slash, 2 numbers for the day, and 4 numbers for the year. Okay, and you can choose your own separator for, this is a CSV file. So I forgot to tell you, the input for the app, it's always a CSV file. There is no quoting, so quoting is unneeded. And what else? You should avoid putting your separator within the text, because this will generate problems. So if you use the comma should be removed first from the text. So if you download tweets from the app, it's already, all it's done by the app, okay? If you use, I don't know, the vertical pipe, for example, it is less common that the vertical pipe will appear in the text. And so it's better. And so these are the basic requirements for the file that you have to upload. So UTF-8 encoding, no quoting and no separator in the text, text in the first column, date in the second column with this format, anything else it's needed. So we can do a test. So once I have downloaded a data set that I like, I can go on input, text file uploads. And both in the documentation, if you go on input, you have a recap of what I was saying, right? So the characteristic of the input file, and it's also reminded here. So you go here and you drag and drop it, or you just upload it, and that's it. And if you get this successfully uploaded tick, it's a good sign. So once you do the, each of your accounts comes with a limitation, because this is a shared server and it's computation, it's intensive on this server. So if you need more space for maximum size allowed, just drop me a line and I will upgrade your account. So what you do is you fetch data, you give it as an input, and always you validate it just to be sure that everything looks good, okay? So let me see here. So validation, yeah.
Do you have any suggestions of why I might have an error in the search query? I actually found the
Let me see. Did you change your password or not? Okay, so please share, because this is what I would like also to do in the last part, that you try and I come and solve errors. And let's do this also while we...
Andrea, I'm sorry. Just wanted to let you know that it's really hard to hear people in the audience and questions. So if there is any question that is important for everybody, if you don't mind repeating it, what you say is very clear, but there is a very bad sound coming from the.
Yeah, thank you for letting me know. I'm wondering if that microphone is working, and so we can test it and share it among participants who want to make a question. So let's give it a try.
Hi, hello, can you hear me?
Can you
Wonderful.
hear?
Yes, that's wonderful.
Okay,
Okay.
so it's solved. Okay, so whenever you want to make a question, just share the microphone, and hopefully do not
Thank you.
share COVID with the microphone. So okay, so Julia, I'm logging in your account so I can see the kind of search query that, oh no, you didn't save it.
Oh, yeah, I can, set. Let me see.
If you set the query, then I refresh the page and I see it. Okay, now I see it. Okay, so this is what you can do when you work in groups, you see. We are both logged in Julia's account, and so, okay, so plastic recycling or advanced recycling, okay. Okay, this kind of error that it's unreadable that you find here is probably because the API key is wrong. So okay, but it depends. Did you copy and paste the bearer token, which is a very long, because sometimes they give you more API keys like the token, the secret and something, but you see, if I click on change API key, it will ask you for the bearer token of.
Yeah, I put the consumer key. Yeah, there's consumer secret that is one one, so I put the short one.
No, it's neither of those. It's the bearer token. So consumer key and consumer secrets won't work. So it's a good point that we made. So you can, but the query was right. So, okay. So what we do is we just remember the system, which was the separator that we chose. So we put the comma. And there is a minimum length of the textual documents, which are tweets in this case, and it would be 3 characters, at least writing THX to say thank you or something. And then you can choose other commands, but I suggest you a dry run at the beginning where you just specify the separator and the minimum document length. So I click on validate, and this will validate my file. So I see if there are errors, and then I can correct them or do some more sophisticated analysis. So I click on check status. It has already finished. It says validation has ended. I found some errors. So first of all, it gives us a recap of what we are analyzing, and we look if it sounds from the file that we have in front of us. So we have 3,500 tweets, which corresponds to the number of lines of the file. These new windows, it's very boring. Okay, so you see there are 3,561 in this file. So it corresponds. And also the starting date, I mean, it's July 6th, and the end date, it's yesterday, July 11th. So it looks good, but we have an error in the first line. Can you figure out why? Yeah. Pardon? Yes, sorry. Yeah, because it's difficult even for me to hear. Yes, it's that one. That you see the first field, it's okay because it's text. It can be whatever text, but being a header, then the second field should be a date, and it's not. So the software, it's telling us you have an error in the first line. If I want to remove it, I can either remove it on my PC and re-upload it, or I just rerun the validation and I click on remove lines with errors. So this will clean the file, and the file will stay on the server clean. So you see it's already finished. And then if you want to download the clean input, you just click here and it will download the clean file. You can also do some more sophisticated analysis, like if you use the third column to input source weights, you can validate that. Please also remember that the software will ignore everything that is from the third column on. Okay, so now in my input file, I have all these other columns that won't be validated and will just be disregarded in the analysis. So, and then you can search for documents that includes specific words, all these words. So it would be an AND operator, at least some of these words, or excluding some words, because I don't know, maybe there is TIM, T-I-M, that is this incumbent in telecommunication in Italy. And when I look for their tweets, often I find tweets about Tim Burton, the director, or Tim Cook from Apple, okay? So I need to clean that kind of text. I should remove it when I do the search query at the beginning, but if I run the analysis and I see that there is some noise in my data, I could, for example, input these words here, I don't know, Tim Burton. I could put it here, or a list of words that I want. So I will identify all the tweets and I can remove them, or I can also select just them and remove the others. So this was the fetching and the inputting. Is everything good for now? Okay. So then you would set the parameters. So for setting the parameters and running the main analysis, I will show you what I have done because I have a case study. And then later we can go back to plastic. And so you tell me what I should put. Okay, so let's see. So I will log on this other account. Also because I have written a paper with Francesca about this case study. So if you forget about something, you have the paper to guide you if you want to go back to the interpretation. So in this case, I had validated a file, which is a reduced version with respect to the one published. So it's 67,000 tweets about fashion brands in a specific week that was between the 5th of March and the 12th of March, 2021. We were analyzing tweets about famous brands, and among them we focus on Gucci, Prada, and Fendi, okay, which are famous fashion brands. So the parameters for the main analysis are the most difficult settings of all the app, okay, because it's many of them, but each one of them, it's pretty simple. It's just that they are many. So if you forget, then there is the documentation. So you see the first one is trivial because it's the name of the file you uploaded and it will be already filled in by the app. The second one is again the separator that you are using, the comma or the vertical pipe or whatever. Then you need to specify what is the time unit of your analysis. Because, for example, if I have 1 year of tweets or 1 year of news, I might want to get a value of the SBS every week or every month, okay? If I have just 1 week of tweets, I would like to have a daily score. So here you can choose days, months, or years, or if I want to do a weekly analysis, I will start with Monday and I will say days 7. So it will give me a result every 7 days, okay? Here I just keep a daily result and I put a start time and an end time because maybe I have tweets from March the 5th, but I would like to start my analysis from March the 7th. So here you can define the boundaries of your analysis. Then you should list in this way, without quoting and separated by a comma, the brands, which can be pasta, pizza, and whatever, or Biden and Trump, or it can be names of fashion brands, like in this case. So I've listed Fendi, Gucci, and Prada. Then you can specify a language from the analysis. If you have multiple languages, you should separate files, because there are functions that are designed for specific languages. So there is part of the analysis that you can make regardless of the language, given that you know all the languages, but you can analyze even tweets which have 10 languages altogether. But for some other analysis, it would be better to have them separated, because, for example, the way stemming or lemmatizations are performed heavily depends on the language. And so you need to know the language and have it consistent for carrying out that sort of operations. So for these languages, we can do everything, which is Dutch, English, French, German, and Italian. But then you have many more languages that you can use. But for example, for Polish, to give you an example, we don't have sentiment analysis. So you can leave whatever the language here and correct later in other settings if you are analyzing tweets in Russian or in Polish or in other languages for which we don't have sentiment. Sentiment, it's only for these 5 languages at the moment. Then you need to choose if you want to generate topic models, if you are not interested in that, or if you want to only use this parameters function to run topic modeling. So disregard all the other settings. So in that case, you click on yes and only, and it will only run topic modeling. Here we leave it yes. You can receive an email when it's finished. And here you choose the filtering of the network, because when you have, when 2 words in a network co-occur only one in the text, then the link connecting and then as a weight of 1, and you might want to remove it because it's, unless the text is very, very little, it might be a random co-occurrence, right? So you want to remove that link. So here it will keep all the links that have a minimum weight of 3, okay? If you put 30, your network will, depending on the data set, but it could be empty. And so you will get an error in the analysis. So, but if you already put 2, you will remove more than 50% of the links, because most of the links which produce noise have a weight of 1. So I would never put 1 unless it's a very small text. I would put at least 2. And in most of the analysis, I usually put 2 or 3. Okay. Also, because if you do it daily, it means that you should have at least 3 co-occurrences per day. Okay. If I have a year of data, you can put a much higher number, because then you would have much more frequent co-occurrences, but it always depends on the time interval that we are choosing. So these are the basic parameters. When I'm happy with them, I just click on generate parameters file. And if I didn't make any error, I will have a message here that says that it's fine. Here are some advanced options, but you don't, for many of them, you can stay with the standard. So the 2 most important are these ones. So stop words, we have dictionaries. So we know that the word of and the word and are stop words for the English language. So we don't need to specify them. We just need to pick the language for stop words. You see now English is selected. If you have tweets in English and Italian, you can, or English and Dutch, you can select multiple languages. Okay, but we will stay with English. On tweets, for example, you have the word RT that stands for retweet, that it's appearing very frequently. So I want to remove it in this analysis. I will just list all my custom stop words here. So you can put whatever list of stop words you want to remove customly. This is the most, in the structure of the input, this is the most complex field that is used to combine in the same node words that could be in different nodes. So if you have a brand that it's made in Italy, for example, sorry, I have a question, let's say. Okay, Leslie, we will share the recording with you, and we'll wait for you to be back. So cluster brands, it means that if I have synonyms, I can use this syntax here to define synonyms, or if I have composite words like Lady Gaga, I can use it to combine words. Okay, so here it would be outside of the cluster. I have quoted a single word without white spaces that represents a labeling for the clusters, right? So I could also then put it in the brands, because for the brands, you cannot use the white space. So you cannot write Lady space Gaga. If you have such a brand, either you create a label, which can be Lady Gaga altogether, and then you define a cluster. So if one of your brands, it's made in Italy, I can write it in this way, MII, and then I will define a cluster that it's MII outside the cluster, and within the square brackets, I will list all the keywords related to made in Italy. So here I have Lady Gaga and Gaga. I don't know if, for example, let's make up a word that it's Gaga Boys that could be referred to Lady Gaga. Then I could also use an asterisk at the end of the word. So this would take all the words starting with Gaga and ending in any other form, okay? So this, it's very important if you have brands that are represented by concepts, and so you need multiple words. This is the use of this field, and this is the use of this other field. Then you can choose between stemming and lemmatization, as you were asking before. Do you know what lemmatization is and the difference between the two? No? Okay, stemming is removing the word affixes, as I was explaining before. Lemmatization, it's a different algorithms that brings every word to its dictionary form. So it needs a dictionary, and it needs part of text recognition in order to do that. I usually use stemming because it's more effective for the analysis I do, but some people like lemmatization, and lemmatization could be better for languages like Italian, for example. So you have that option. If you want to make an analysis in, I don't know, Portuguese, you can pick Portuguese for the stop words, and you can pick Portuguese for the stemming. So it will ignore that you put English here, and it will calculate everything apart from the sentiment. Then what else? I would leave this connectivity approximation and distinctiveness centrality alpha coefficients to the value of 1. So this is very advanced. In the analysis, you can just disregard it. I've never changed it in my analysis so far. Here you can just select to generate a graphical report and calculate sentiment if you want to use the source weight, the co-occurrence range for defining the network links. So we take a threshold of 5 words distance, but you can change this, so it can be 1, or it can be 20, or it can be less, because it doesn't make real sense to make more than 20 when you remove the stop words. And something that you can change here that it's interesting, it's the percentage of text that should be analyzed. Because if you have tweets, you want to analyze all the tweets. But when you have news, sometimes I get better results if I put 0.3 here, because I will only analyze the title and the lead of the news, because people, when they go on online newspapers, they only read the title and the initial part of the news, and they don't get information. Very few of them read all the article. And so, for example, for voting intentions, you get better results if you only analyze the 30% initial part of the article, so the title and the lead. And these are parameters for topic modeling. So here it's the maximum number of topics. Here it's the a parameter internal to the Louvain clustering algorithm, if you know it. And you can also choose, but this is very slow because the software will match brands with topics. So it will tell you how much Biden is in the topic of Ukraine impeachment. But it won't match the documents. So here you can match the documents, and so you would have, for the 67,000 tweets, you will have an indication of how much each tweet is connected to each topic. So if you want that kind of result, you should flag match topics with documents. And that's it. You can put a name here, and this configuration will be saved in this page. So you can delete or import a pre-saved configuration. So this was the most boring setting page for the analysis. And the same settings you will find in the other pages. So once you learn this one, it's all set. Do you have doubts about these parameters or these settings? I mean, they are many, so maybe if you forget later, you have in the documentation, or you can ask me. Now I want to show you, I mean, before we take a break, it could be useful that I show you the results of the analysis that we do. So then we look at, after the break, we look at the extra functions and network analysis if you want to. So when you go in the analysis, you go in SBS run or saved reports. SBS run is where I run the main analysis. So I input the file, I validate it, I set the parameters, then I run the main analysis. But there is an internet connection problem. Okay, when I go in the analysis, you just click on run. I'm not doing this because you see it took 2,400 seconds, which I don't know how much it is in minutes, but it's quite a lot. And so I don't want to waste our time now, just because this is a quite big analysis, but other times it takes less than 1 minute, it depends. So you will get a message, then the analysis is running. We can do on the tweets that we downloaded later, and it will take seconds. Once it has finished, you should get all these buttons here. So you can download the results, which we will see in a second. It will give you a zip file with the results. You can look at a graphical report instead of looking at a bunch of Excel files full of numbers. You get immediately a report and an indication of what you are doing. You can save it. So if you save it, you will find it here, and you can access it in a second time. It will only save the report. So if you want the full set of results, please download them and save it on the side. And it's not usually interesting for people who do not do social network analysis, but you can also download networks. And so the networks, again, are in PIAC format. So if you want to analyze semantic networks also with some other software. So these are the files that you get. So these are the files included in the results file. And these are the networks that you would get. So the networks are in the PIAC format, so they get this kind of shape. The declaration of vertices with their numbers and labels, and then at a certain point you have the links connecting each vertices with the weight. This is an undirected weighted network. So you see here that you get a network for each time period of analysis. So just because we said 1 day, we get a network for each day. And in the results file, I mean, now it's a nightmare because it's many files. I'm not going to open all these files. I just show you, for example, then in SBS results small, we have each brand repeated for each time frame of analysis. So we have Fendi, day 1, day 2, day 3, and so on. We have the number of documents that appeared in that day, the sentiment for that brand, which is important because it's only related to that brand. So if I have a long text document, which is speaking good of Fendi and bad of Gucci, I will have a positive sentiment for Fendi and the negative sentiment for Gucci, and not an average sentiment score for all the document. And then you have measures for prevalence, diversity, and connectivity, and the final SBS, and a different normalization score here. And again, the sum of the different normalization. So this is the row coefficient. When you see COEF here, it's the row coefficient. When you see STD, it's the standardized coefficient. And when you see underscore 100, it means that it's a min-max normalization. So this value changes from 0 to 1, okay? I know this is ugly and probably too much. So now I show you the graphical report, which will look like this. Hopefully, okay. So it's much better. Instead of getting all the numbers, which I wanted to show you, because if you do a forecasting model, you might ask me, where do I get the numbers, okay? But if you want to produce a company report or even just a research when you need to look at the results, here you get the absolute values of the SBS over time. So you can see that Gucci is the most important brand in this week of analysis. These are the overall scores compared to the full discourse, okay? Sometimes I'm only interested in looking at the proportional strength among competitors. So if you click on the tab proportional values, you will get percentage scores of one competitor with respect to the others. This is useful when you do political forecasting because you have the share of importance of each candidate, which would hopefully translate in the share of votes. So the first kind of graph, which is interactive, by the way. So if you go on a dot, you will see the brand, you will see the day, and you will get the SBS information and the values of the 3 dimensions. You can also, let's say you want to compare Fendi and Prada and exclude Gucci, you can click on Gucci and you will get an updated graph. So this is all interactive graphs. You can zoom it on some days, okay, and do whatever you like with this kind of graphs. The second set of results, it's positioning. So you get the SBS on the vertical axis and the sentiment on the horizontal axis. So you can see that not only Gucci is the most important, but it's also the one with the highest sentiment on average. But we can have this as a dynamic temporal analysis. It's better when you have more data points, but you can pick a specific day and see if the picture was different on that specific day. Then in the third tab, you have a recap of the main indicator, this time normalized between a score of 0 and 300. And you see the contribution of each dimension to the final score. So you see how strong is prevalence, diversity, and connectivity for each brand, when you can also get a graph only for prevalence, for example. Again, to provide recommendations, okay, what should the company do, or what should researchers or people interested in recycling do if they want to spread the message more, for example. So these are based on numbers, okay, but then we need to make sense of these numbers. So what we do in the subsequent part is we look at what makes the sense of our analysis. So in this tab, we can look at the words that are mostly associated with these brands. So we can see Gucci, Fendi, and Prada. These are the top associations, which means that are shared among brands. So I could have, I don't know, the word collection here could be associated both to Gucci, Fendi, and Prada. Okay, let's zoom on Prada, for example. You see, fashion is the word most associated to the Prada brand with 1,454 occurrences. But probably the word fashion could also appear, I don't know, in Gucci. Do we see it for Gucci? Not in the, yes, there it is, 1,619. Okay, so this is not making a real distinction. Well, it will vary in weights, but doesn't make a real distinction between brands. So if I want to see if there are words that are uniquely associated with a brand and not with the others, I should click on the Unique Associations tab. And now I see that the word Kai, for example, do you know Kai? It's a K-pop singer. I didn't even know Kai, but Gucci, it's very much prominent in this analysis because they launched a new collection in Korea, and it was connected and sponsored by this K-pop singer Kai. And also there is a discourse about Lady Gaga, because at that time they were filming the House of Gucci movie. Okay, so this is where you make sense of what is happening. Or if you see, I don't know, let me reset the graph. If you see a spike of some brand in one day, you can also look at the most frequent words of that specific day. So I don't know, hello, okay. This day was March 10. So I can go here and pick March 10 and see what were the most frequent words in that day. So this you use to make sense of your results. And this is about direct association. So it's what makes the brand image. What are the words that are co-occurring with my brand? But brands could be also associated with indirect topics. So we will see that in a second. In the tab of brand similarity, it's like when I was showing you, let's see it on this website. I mean, the main website for the app, it's semanticbrandscore.com. If you click here, we have a demo for Biden, Warren, Sanders, and Buttigieg. And so the brand similarity graph, it's more meaningful on this demo. So it is the graph that I was showing you from the slides. So the more close 2 points in the graph, the more they have a similar image. And again, you can see how this evolves over time. Okay, if they stay the same or if they change, and how this change happens in specific days. So we can also look at it for Fendi, Gucci, and Prada. So we see that Prada overall, it's more distant from the two other brands. It's less interesting because there are just 3 points on the graph. Then we have a graph that tells us which are the most central words in terms of connectivity, so in terms of betweenness centrality, and which is an initial suggestion on what are the words, the topics, the concept that I should connect to in order to improve my connectivity. But as I told you, we are developing a separate app for this and a simulation method to better tell you which are the specific words that could improve the connectivity of a specific brand. And the very last is the topic modeling. So for this kind of data, the software has identified 12 topics. I can play with this graph and zoom and look at these words and also reorganize the position of the cluster. So this is topic 7, and these are the words characterizing each cluster. And you also have, I mean, the thickness of a link. It's a proxy for the connections among topics. So you see that there is a lot of connection between topic 2 and topic 1. and the brands are indicated in red. So each brand is usually connected to more than one topic, but in the network graph, each brand will appear on its main cluster. Okay, then you have a more fine-grained analysis in the following. So I understand that looking at the network, I mean, we are network people, but for people who are not used to network analysis, this is very exciting, right? So they look at this graph and they say, wow. For us, it could be boring to go in the nodes and read at the words, and it's complicated. So you just click on this button here, show hide, and you get a list of each topic with the keywords and even a score that it's giving you a proxy of the difference in importance between the first word and the second word and so on. So you see, for example, that the first topic, it's about the Kai Gucci launch. So the Gucci, the event organized by Gucci. And then we will have another, for example, topic related to the Lady Gaga movie. So here they were filming the part of the Lady Gaga movie, the House of Gucci movie, where Lady Gaga was one of the protagonists. So what you do, as you would do with LDA or other topic models, you read these words and you give the topic a meaning and manual labeling. You would also notice that if there are some words that are like noise, but you have a score. So, I mean, for this topic, Fendi, it's much more important than Laurent, or I mean, earlier here, it's much less important than Lady Gaga. And so sometimes if you have words that don't make sense, you just remove them. I mean, ignore them. And also, this often happens when people write in different languages. So for example, you make an analysis of tweets in English and you will find somebody writing in Italian. Then you will have a topic clustering all the Italian words, and you don't need to use all the topics, right? You can drop the topics that do not make sense. So the importance of each topic, it's represented here. So you see that topic 1 is the most important, followed by topic 2, and these are also the most connected among them. And topic 6, it's of very little relevance. So maybe I don't need to report topic 6 in my analysis, or it could be something that it's peripheral, but still important and you want to comment on that. But I mean, I'm just showing you the app here, not the specific case. So this is how you can use the app to carry out network topic modeling. And here you get the association of each brand with each topic. So Gucci, it's mostly associated 51% with topic number 1, and 20%, about 20% topic number 2, and so on. Whereas Prada is mostly associated to topic number 5. You have also a inverted graph, because you could have, for example, I could have a very small brand, 100% associated with one topic, but in general, that brand, it's not important for that topic. So it appears very rarely, and when it appears, it's always connected to that topic. But for the topic, the brand, it's not important because it only appears rarely. So if you want to see how much each brand is important for each topic, you should click here, and you see that Gucci, it's the most important brand for almost all topics, apart from topic number 5, where Prada has the leads, and topic number 3, where also Fendi has 36% of the importance. So this is all about connecting topics and brands, or in the output. So when you go in the results file, you also have, where is it? SBS, topics, docs. If you really want to do that, because in LDA you get that kind of results, you will have document number. You see you have 67,000 rows here. And for each document, you see how much this document is associated with topic 1, with several weighting schemes, topic 2, topic 3, and so on. So document number 1, it's more about, it's more about topic 1, but this is more advanced, let me say. So this is really the main analysis and graphical reports produced by the app. So it's a very good moment before we take a break to ask me all the questions you might have regarding this one. And then I think after the break, I will briefly cover these functions and then let you play with the software, because it's, I see you are jet lagged like me. And so it's me talking all the time can be very boring. I understand. You have a question? No. Okay.
What did you use when you were changing the file to ensure that it was in TF8?
It's yes, it's Notepad++. It's a software. Do you have Windows or you have Mac?
I can operate both on this computer.
Okay, so this would be the best if you can operate with Windows. Otherwise, there are other advanced text editors if you only have Mac, and one of them is Sublime Text, which can change the encoding, I guess. But Notepad++, it's really the simplest, and it also runs on Linux. So I use that because it's the simplest in my case. So you go in the encoding menu. Here you can see the encoding. And if you want to change it, you click on convert and you save it when it has been converted. And then you can convert back before uploading on the software. Any other doubts or question?
And the fetch function doesn't automatically take out the header. So the thing that you need to do is first delete header, ensure that it's in the correct format, then do the validation in the app.
Yes, exactly. When you fetch it, just because it's many different fields, the app will leave the header in, because maybe we forget what the 4th column is. Okay, so if you don't change the file, you just re-upload it in the app and you validate it, it will always tell you that there is an error on line 1, but then it's easy, you remove it and that's it. But I'm going to show you is, for example, in the validation, where was it? Okay, so I'm back on the page where I have the plastic data file. Let's say I've put a wrong separator here. So it will not recognize the comma as a separator, and I run the validation. The picture will be very different at the end of the analysis, because I click on check status and I will find an error on all lines, okay? So if you find a situation like this, either you put the wrong parameter here, or there is maybe you are using the wrong encoding, or people wrote something very strange in the text. There are strange characters that are not recognized. So it's always better to check. Yeah. Any other question or doubts?
So when you do the analysis, you mentioned advanced. Things. You made a few decisions based on your understanding of the software. So this is requests. You have the heuristic, your flow chart of the 4 processes.
Yeah.
Because you've got a lot of things to fill in there, and I don't know why you, like, for example, you had copy and quote and
Yeah.
retweets. Now it assumes that I can understand you don't want retweets.
Yeah. Okay.
And
Yeah.
then, you started putting in, like, with plastic recycling, I was thinking Coca-Cola is 2 words in 1 word.
Yeah.
And
Yeah.
so I started looking at what's these 2 brands, Coca-Cola and Pepsi-Cola, or Pepsi. And I was trying to figure out how do I manage that.
Yeah, this is why I want to cut my time and give you time to experiment, because these are just examples that I put here, because sometimes people write, or when you download data from news, you have HTML tags, which is a noise. And so in that case, you would put HTML tags there in the stop words. When you have brands like Pepsi and Coca-Cola, you should use this field here, right? So maybe you write Coke, and then here you have Coca space cola within quotes, and it will take care of that. So it's just taking a little bit of practice with the software. I understand now it's all new. So even if you go on the documentation and parameters, it gives you a brief explanation for every field. So if you want to know why I told you that you should, for connectivity approximation, I tell you always put the parameter of 1. But if you want to better know what this is, either you ask me now or you go in the documentation and you get more precise description that is calculating between the centrality, not approximatedly, but exactly, for example. So yeah, but this is the meaning of me being here. So to answer all questions.